Okay, starting with polar stuff now. We want to, on number 14, find the rectangular coordinates of the point with the given polar coordinates. So they're telling us these are polar coordinates, which means they've given us an r and a theta. We want to change these to an x and a y. And so you should have on your unit circle card something that relates r and theta and x and y, because we know that x equals r cosine theta, and we know that y equals r sine theta. It has to do with the fact that we could set up a triangle for this. So we want to do square root of 3 cosine pi over 6 for the x value, and square root of 3 sine pi over 6. And these values are on the unit circle, so we want to use what the cosine of pi over 6 is. So you look at your unit circle over there in the first quadrant, and you should see that cosine of pi over 6 is square root of 3 over 2, and sine of pi over 6 is 1/2. So we need to multiply each of those by square root of 3, which gives us our point. Square root of 3 times the square root of 3 is 3. So the first part of that is 3/2. Square root of 3 times 1/2 is square root of 3 over 2. And you should be able to graph these 2 points and see that they end up somewhere close to each other as a way of checking yourself. Remember, and actually we're about to do this in 15, the way we graph a polar coordinate, which is r and theta, is go with the theta first, which is in this case pi over 4, so that's a line out this way, halfway between 0 and 90. Because pi over 4 is 45. And then for -2, we actually want to go this direction. The solid line I have drawn is for positive r values. The dashed line is if we have negative r values. So if we're going -2, you can make a little circular thing here, either all the way around, or you could do it just for this quadrant. Like -2 should be about right here. So yeah, like right there. 16. We want to find all of the polar coordinates based on what we're given, and we have a formula for that is super handy that I don't remember off the top of my head. But you don't have to either. It's on your unit circle card. Let me just open up my handy dandy pre-calc book. Okay, let's try this again. The formula says r, which r is -6, comma, theta, which is pi over 3, plus 2n pi. Okay, the only thing that we can fill in the formula is r and theta. And it says or, and it says -r, so this is where we have a -6 is a +6, comma, theta, which is pi over 3, plus 2n plus 1 pi, goes your parentheses. So if they ask us to find all of the polar coordinates, this is what we're supposed to put, and we're saying that n has to be an integer, so you can use the n is an element of zit integers, that fancy notation, or you can just say, if you want to, n is an integer, if you want to spell it out. Either way. 17. Find an equivalent equation in rectangular coordinates. We have r's and thetas. We want to write with x's and y's, and technically as soon as our r and thetas are gone, we've converted it, and it kind of depends on you / your teacher how far after that you need to go. So we want to use these relationships, which we have written on our unit circle card. X equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. And in this problem on 17, if I distribute the r, some of those relationships show up, so I should go ahead and do that. Now r cosine theta I can replace with x, r sine theta I can replace with y. That equals 5. So like I said, this technically is a pretty good answer. It would be just as good if we solved it for y, but we don't necessarily have to. That wasn't mentioned anywhere in here. It just kind of is a preference sort of thing. On 18, the problem is we have an r here, but what we want is an r in front of sine and cosine. So what we need to do is just put one there by multiplying the entire equation by r. If you want an r one place or even two places, you have to put it everywhere so that you keep your equation balanced. So I'll make this r squared minus 3r sine theta equals 6r cosine theta. And now we can just replace up a storm because r squared is x squared plus y squared minus 3r sine theta is y equals 6 r cosine theta is x. I will say that it would probably be preferable for us to either write everything on one side here. I mean, that's probably the best idea. Like, as far as simplifying, you can't really, I mean, you can solve this. No, it's difficult to solve this for y. That's not something we really want to tackle. So that's 14 through 18.